Hello, sixth graders. This week we're going to be working on some algebraic equations, and I don't want anyone to freak out by the word algebra. Basically, we're going to stir some unknowns, some variables, some letters into our alphabet soup, and it's not going to be that bad. I've got a few simple rules for you to follow. So let's check this out. Some things we already know. We know that an equation is a number sentence. You know, I hate that phrase, but one that has an equal sign in it. So for instance, 2 plus 2 equals 4 that you've been able to solve since you were knee-high to a grasshopper. It equals 4 is an equation you've worked with ever since. It means ever since you were little. There we go. Finish your sentences. It means that 2 plus 2 is the same thing as 4. You can imagine that with a scale. If you had 2 blocks on one side of the scale, 4 on the other, they would balance. You can also make an equation where you have an expression on each side. 2 plus 2 equals 3 plus 1. It means that 2 plus 2 is the same amount as 3 plus 1. Again, imagine the scale. And you can see this one gives you 4. This side gives you 4. We're going to be equal. Now sometimes, and this is true ever since Mrs. Henderson taught you in kindergarten, that sometimes we're asked to find a missing part of an equation. Most of the time in the history of your life, you've been asked to find what comes after the equal sign. 5 plus 2, you sort it out. You fill in the box with 7. There's nothing miraculous about the box. You've just always known you fill it in there. Sometimes you're missing a piece on the expression side. 4 minus some mystery number is 3. Well, 4 minus 1 is 3. So that mystery number, that box, stands for 1. We've started this year, instead of having boxes for you to write in, we've substituted it with some letters. So 5 times something, we're calling it m instead of a little box, equals 20. 5m equals 20. What would m have to be for this to be true? Well, 5 times 4 is 20, so m has to be 4. We've talked about that a little bit this year. We're going to take it a little bit farther. All of these were problems that you could do in your head with probably half your brain tied behind your back. But what if you don't just know the answer? What if it's not one you've done so many times that you just automatically know? Well, we're going to go to an actual scale to figure this out. I'm sorry, the cat is climbing the screen and the dog is barking at it. This is what home distance learning is like sometimes. Sorry about that. So in my first bag, I've got some things in here and an equation to work with. I've got a chicken figurine and 13 blocks. Chicken plus 13. And I'm going to put that in one side of my scale. Come on. And that equals 78. 78 of these little unit blocks. On the other, well, it was equal when we did this earlier. There we go. We're going to call it equal because this is a little plastic scale. It may not be a precision instrument. So chicken plus 13, C plus 13 equals 78. What would we have to do to find out how much just the chicken weighs? Well, probably a good start would be take out all the blocks that are in there with the chicken. So we're going to subtract out those 13 blocks so we have just the chicken. That might be something to do. So we had chicken plus 13, we got rid of 13. Now we've got just the chicken over here, but we've got a problem. We're not balanced anymore. Dang, so this is not equal anymore. What would we have to do to keep it equal? Well, let's take 13 out of this side. There's 5. 6, 7, 8, 9, 10, 11. Again, not a precision instrument, we're okay. So I took 13 out of this side, I take 13 out of this side, and then we achieve balance. So that chicken weighs 65 blocks. Yay! What we've done here is we started with addition and we used something called the inverse operation. The inverse operation is the backwards. So we had addition. Backwards of addition is subtraction. Inverse operations of add is subtract. We also had to take those blocks from both sides in order to keep our scale balanced. Let's try what we've got in my next bag. Oh, of course, now I have to eliminate all this stuff. Okay. Yeah, cat, go ahead and steal the blocks. It's okay. My next equation looks like this. I have a pudding cup. But, Katie got hungry. No, that's not true. I took a bite out of it. I have some missing. So this is a pudding cup. And I ate out 31 blocks worth of pudding. And that left me with 86. So my pudding cup, when I took out 31 blocks worth of pudding, equals 86. Well, what am I going to have to do to find out how much the pudding weighed before I started eating it? Well, let's put those, I'm not going to throw up the pudding. Don't worry. What I thought I'd do is put 31 blocks back in. If I had pudding minus 31 and I added 31 back in, that would be the original weight of the pudding. But sadly, we're out of balance again. In order to get it back in balance, I'm going to have to also put 31 blocks back in this other side. And it's also helpful to open up your Ziploc baggie. Now we have as close to balance as my little inaccurate scale is going to get. 6 plus 1 is 7, 8 plus 3 is 11. So my container of pudding, when it was whole before I ate it, weighed 117 blocks. Yay! You'll notice again I used my inverse operation. Inverse or backwards of subtract is add, and I did it to both sides. Bye-bye, pudding. Katie can have the rest of you later, or I will. My next equation is a multiplication equation. I have these little plastic popsicle top thingies. You can make popsicles in the freezer. And I've got 3 of them. So 3 popsicle toppers. Now, this is probably also one you could just know, but I'll show you what this looks like anyway. 3 popsicle toppers weighs the same as 9 blocks. So 3 popsicles equals 9 blocks. But what would we have to do to find out how much just one popsicle thingy is? Well, let's take our popsicles. We're going to divide it by 3, because I've got 3 of them. I'm going to divide by 3 to leave myself just one popsicle topper. But we're out of balance. If I'm going to divide this side by 3, I also need to divide this side by 3. So 9 divided by 3, that should leave me 3 blocks. And each popsicle topper weighs the same as 3 blocks. Again, I used the inverse operation. We started with times, 3 times p, and we used the inverse operation. We divided to get that popsicle stopper up by itself. And finally, I don't need to do that one. That's just 3 blocks. Finally, I've got a graham cracker. This is 1 whole graham cracker. But let's say I don't actually have one. Well, I do. That would be the easiest way to find out what 1 graham cracker weighs, is I could just weigh it, but that wouldn't be any fun at all. Instead, I've got half a graham cracker, or a graham cracker divided by 2. You guys are 6th graders. You know we can show division as a fraction. So half a graham cracker weighs the same as 8 blocks. But what could we do to find out how much a whole graham cracker weighs, besides just putting this in here and weighing it, because I'm not going to do that. What I'd have to do is use my inverse operation. Inverse of divide is times. So I'm going to multiply that by 2. Graham cracker divided by 2 and then multiply it by 2 gives me 1 whole graham cracker. But we're out of balance. In order to put it back in balance, I'm going to have to do the same thing to the other side. I'm going to have to multiply that 8 times 2. So there's 5, 6, 7, 8. 8 times 2 is 16, and sure enough, 1 graham cracker weighs the same as 16 blocks. Nice. So you've seen an addition, subtraction, multiplication, and division equation. Couple things I'd like to point out just to make your life easier. When I was a kid, my dad taught me most of the math that I knew because I'd come home and get all frustrated, I'd be crying, and he'd be like, let me show you this. So he found some simple ways to share this with me. One of them was DBLA, Daddy's Basic Law of Algebra. He used this a lot. Trust me, I don't just make this stuff up. My dad was as weird as I am. And that rule is whatever you do to one side of the equation, you do to the other, which is exactly what I was doing here with the balance. If I took some out of one bucket, I had to take the same amount out of the other. We've got to keep our sides of the equation even. The other thing I'd like to share is, yes, there is a math song to go with this. Vanson, in your spare time, make a nice, I don't know, equation dance to go with it. This is a song to help you remember that whole inverse operation. Use the inverse operation, use the inverse operation to make the variable stand alone, which means by itself on one side of the equation. The variable stands alone, woohoo, I found the answer. The variable stands alone, dun-dun. Thank you. So let's do a couple without the scale just so you can see what it'll look like on your paper. If I had m plus 36 equals 182, you can always make a story out of it. There's a monkey with 36 pounds of something in a box with him. And altogether, that box weighs 142 pounds. How much does just the monkey weigh? Well, I'm going to use the inverse operation. Inverse of add is subtract, and I'm going to do it to both sides. And I'm going to take those extra things, pounds, that are not with the monkey and subtract them out so that the monkey is by himself on one side of the equation. Then I'm going to have to subtract 36 from the other side. Good old subtraction. And the monkey weighs 106, or m equals 106. For a multiplication equation, I'm going to have to do the inverse of multiplication, which is divide. If I have 3 monkeys, or 3 m's, or whatever m's are, 3m equals 192, I'm going to have to divide that by the 3 so that I just have 1m. I've got that m all by itself on its side of the equal sign. Then I'm going to have to divide, oh, I know we all hate division. I'm going to have to divide 192 by 3. 3 divides 19 6 times, with 1 left over, bring down the 2. 3 divides 12 4 times, so m equals 64. If I have a division problem, very likely it's going to be written as a fraction, and that is okay. C divided by 5 equals 15. So I'm going to multiply. Inverse of divide is multiply. I'm going to multiply each side by 5. C divided by 5 and then multiply it by 5 again gives me C. Then I'm going to have to do 15 times 5. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. C equals 75. One more for jollies. Katie's telling me we're just about out of time. B minus 114 equals 215. Inverse operation of subtract is add. So I'm going to add 114 to both sides. If I subtract 114 and add it back on, that leaves me just with B, the variable standing alone. And then I've got 215 plus 114 gives me 329. B equals 329. 6th graders, I hope you have fun with this week. We're starting with office hours this week, so if you have questions, you can pop in. We'll have an explanation in an email. a Zoom meeting where you can just pop in and ask your questions and pop back out. You don't have to wait for everyone's questions, just like if you were stopping by to visit me. That's going to start on Tuesday and Thursday, so watch for an email that's going to tell you how to join up with that. Have a great week, and I will see you next week. Bye-bye.